In this video, we're going to look at graphing sine and cosine functions, but this time we're adding shifts to the mix, okay? So vertical shifts are not so bad. The horizontal shifts definitely cause, a little bit more struggle, okay? So we're going to start with vertical shifts, okay? So if we look at this function, first of all, we have a vertical shift of down 2. You'll notice that this -2 right here tells me that we have a vertical shift. Okay, so a vertical shift of down 2. So I'm just going to kind of put that out to the side a little bit. All right, now my amplitude is 3. So A is 3. Remember, amplitude is not the number that's just in the very front, because this is being added or subtracted. What the number being multiplied to the sign is 3. So amplitude is 3. Period, because it is sine, is 2 pi over b. All right. Now, b is 4. So we're going to say 2 pi divided by 4, which reduces to pi over 2. All right. So what we're going to look at is we're going to have to set up our graph. All right, now how many increments is a sine graph? Well, remember it's put into quarters, so we're going to have 4 increments. So you're going to hear me kind of refer to things as increments because I'm going to be like, okay, you shift how many increments? Okay, so 1, 2, 3, 4 increments is going to be 1 period of pi over 2. All right, now this is always 0. So, what's a quarter of that? So I'm just going to kind of refresh your memory. So I could say 1/4 of my period is pi over 8. I could say 2/4 of my period, which would be 2 pi over 8 or pi over 4 reduced. 3/4 of my period is 3 pi over 8. Okay, so just a quick reminder of how to do that. Now you can put that in your calculator. I'm just writing it so that you can actually see it. All right, so but that's where my little increments come from. All right, so we're going to go 1, 2, 3, -1, -2, -3, -4, -5. All right, so this is kind of the start of my graph. All right, so now we're going to graph our graph. Okay, now you got to be really careful. Okay, so I'm going to show you how to do it without, a calculator, but I also want to show it to you with a calculator because I really feel like a lot of y'all will probably use your calculator a lot just because you're just going to want to make sure. Okay, so I'm going to do the function in yellow just so that it's really light. And this is without me shifting it. Okay, so my amplitude is 3. So without doing the shift of -2, I would go start at 0, 0 because it's a sine function. I'm going to go over and up in amplitude, back down, and back up. I know that's kind of hard to see, I'm sure. So let's make that a little bit darker. Do yellow because it's not super dark. Okay, but there's your 5 critical values. So I'm going to go up and down and back up. All right, so that is the graph before I shifted it. Okay, but what happens is we take that graph, that's our amplitude, and what do we have to do? Well, we started here, but we have to do what? We have to go down 2. We would have been here, but we went what? Down 2. We would have been here, but we do what? We go down 2. We would have been here, but we go down 2. We would have been here, but we go down 2. So this graph ends up looking like this instead. Okay, so this is the graph that we need to use. Okay, so that's my shifted graph. Now on your paper, I don't need to see this yellow graph. Like I don't have to see that. If you need to do it because you need to see it in order to shift it, then totally okay. But another thing that you could have done is if I knew that this was my starting point, but I needed to move it down 2, then I would say, okay, this is my new starting point. I'm going to go over and up an amplitude. 1, 2, 3. I'm going to go over and down an amplitude. Count to 3. I'm going to go over and down in amplitude, count to 3. Over, count in amplitude, 1, 2, 3. Okay, and then that would give me my graph. The other way that you're going to do that, and this is probably the way that most of y'all will prefer to do it, is you're going to put this in your calculator and you're going to try it at 0, pi over 8, pi over 4, 3 pi over 8, and pi over 2. Okay, so those numbers are coming straight from my graph right here. Okay, my x-axis points. All right, so I'm going to show you what you would do in your calculator. All right, so turn on my calculator. Okay, so I would have -2, because that's in my function, -2 plus 3 sine of 4 times 0. And I got -2. All right, I'm going to do it again. -2 plus 3 sine 4 times pi over 8. And I got 1. I'm going to do it again. -2 plus 3 sine of 4 times pi over 4. And I got -2. I'm going to do it again. And I would have 3 pi over 8. And I got -5. Do it again. And I would have pi over 2. And I got -2. All right. So I basically original function, and after I found these interval markings, these little increments, then those are my x values, and I'm taking those x values and I'm substituting it in for x here. All right. So these are the points that I got. Now notice I have the point 0, -2, check. Pi over 8, 1, check. Pi over 4, -2, check. 3 pi over 8, -5, check. Pi over 2, -2, check. Okay, so I'm kind of showing you some different ways that you can do that because some of y'all are going to prefer to not do all of this and put it in your calculator and all that, but a lot of you will probably prefer to use your calculator. All right, so now it wants to know some other things. So, what are the values on y equals k? Now, the y equals k, this is your midline, okay? The midline is right here. It's y equals -2, okay? So, y equals, I'll try to make it small, y equals -2. That's your midline. And that's y equals k, which in this case is y equals -2. So what are the values on y equals k? Well, on y equals k, you have 0, -2. You have pi over 4, -2. And you have pi over 2, -2. Okay, so 3 critical values. Now notice I didn't call them x-intercepts because they're really not x-intercepts, okay? They're the intercepts of the midline though, all right? So sometimes you'll see them referred to as intercepts because they're the intercepts of the midline, but really they're the values on y equals k. My maximum value is pi over 8, 1, and my minimum value is down here at 3 pi over 8, -5. All right. So let's look at another one. All right, so this one's a cosine graph. So be mindful, like sine starts at 0, 0, but we had a vertical shift of down 2, so that brought that starting point down to 0, -2. Whereas cosine has a starting point of 0 amplitude, so that's going to kind of shift some things. All right, so I'm going to kind of show you more how to utilize your calculator because I think that's where a lot of people are going to be. All right, so the amplitude is 1. This 4 right here, what does that tell us? It tells us our vertical shift is up 4, okay? And then my B value is 2. So 2 pi over 2 is pi. All right, so let's go ahead and set up our graph. So we always know 0 is here, and then 1, 2, 3, 4 increments over is going to be your period. So that is pi. Now, for me, I like to count. I'll still show you how to do it in the calculator as well, but half of pi is pi over 2. Half of that is pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4. So to me, that went really fast. That's how I count. I prefer it, but I know that, the calculator will definitely be a little bit of a crutch for you. So how you would do that is you would say, well, what is 1/4 of my period? What is 2/4 or 1/2, if you want to do it that way, of your period, or 3/4 of your period? Okay. And that would give me pi over 4. That would give me pi over 2 and 3 pi over 4. So again, that's where these little increment marks come from. All right. Now my y-axis, 1, 2, 3, 4, 5, negative 1, 2, and 3. All right. So now we have our graph set up. Okay. So using your calculator, we are going to use these x values. Okay. So 0, pi over 4, pi over 2, 3 pi over 4, and pi. All right, and I'm trying to get the y value. All right, so this is where my calculator comes in. All right, and then I'll talk you through how to do it without the calculator as well, but here we go. All right, just a little bit closer. All right, so in my calculator, I would have 4 plus cosine of 2 times 0. And I got 5. So 0, 5 is one of my points. All right. Now I'm going to do it again. Whoops, didn't mean to do that. Let's try that again with pi over 4. And I got 4. So here we go. Pi over 4, 4. Now I'm going to do it again, but with pi over 2. And I got 3. Do it again, but with 3 pi over 4. And I got 4. Do it again, but with just pi. And I got 5. All right. Now, this is my uterus graph because it's a cosine. So I have a u, right? And then I curve and I curve. Okay. And you want to keep that curvature because you got to think that if you were to keep going, what would this graph do? It would do something like this. Do, 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 do. Like it would just keep going. Okay. So keep them curved. All right, so that is my graph. I got it straight from my calculator. Life is good, okay? So how would we do that if we didn't do that? Well, what you would have to do is you would have to think of, okay, I have a cosine graph with an amplitude of 1. So I would start at 0 amplitude, and then I'd go down, down, up, and up. So this yellow graph would have been my graph before I shifted. Well, then what would I do with that? I would just simply count up 4. I'd go 1, 2, 3, 4, plot a point. 1, 2, 3, 4, plot a point. 1, 2, 3, 4, plot a point. 1, 2, 3, 4, 1, 2, 3, 4, plot a point. Okay. So that's what you could do. Okay. Again, do I need to see this yellow graph on your paper? No, I do not, because I already know that most of y'all are going to be a little bit more reliant on your calculator. Okay. All right. So forget the yellow graph. We have our y equals k. And this is y equals k. This is our midline, which is at 4, which is what you see right here. So y equals 4. All right. So my midline is y equals 4. And what are the values on that midline? Well, they are at pi over 4, 4. And 3 pi over 4, 4. All right. My maximums, I have 2 of them, 0, 5. and pi 5. My minimum, just one minimum at pi over 2, 3. Okay. All right, so that's how we graph that with shifts. All right, so the next two problems are you-try problems. So I want to give y'all a minute to try both of those. All right, so pause the video and go ahead and try those out. And I'll go back over 'em momentarily. All right, so hopefully you paused the video and actually tried these, but let's go ahead and go over them together as well. All right, so for this first one, we have a shift of down 2. So that's a vertical shift. That's not a reflection, all right, because it's not directly in front of the cosine. It's not what's being multiplied to the cosine, all right? But I do have an amplitude of 1 because that would be an understood 1 in front of cosine. B would be like 1x, so B is 1. So 2 pi over 1 is just 2 pi. Now we're going to set up our graph. All right, so we start at 0. 1, 2, 3, 4 increments will be 2 pi. Half of 2 pi is pi. Half of pi is pi over 2. 1 pi over 2, 2 pi over 2, 3 pi over 2. Again, you could set it up in your calculator by doing the quarters, just like we did down here. Okay? But I went ahead and just did them here by counting. All right, so now my y's 1, 2, 3, -1, -2, -3, -4, -5. All right, so we're going to go ahead and sketch our graph. Now, this is where you could utilize your calculator or you could utilize, well, what does a cosine graph look like and where would it be? Okay, so I'm going to kind of show you both ways. All right, so if I was a cosine graph, then I would start at 0 amplitude. So I would start at 0, 1. I'd go down, down, up, up. So this would be my cosine graph. All right, before I shifted. But I need to shift it down 2. All right, so 1, 2, plot a point. 1, 2, plot a point. 1, 2, plot a point. 1, 2, 1, 2. All right, change my colors on you. All right, so these are the points that I would have had because they shifted down 2. And do a U in the middle and then the curvature at the top. Okay, remember uterus shape, make sure it's curvy. All right, so that's where my graph comes from. Notice I didn't use my calculator. That was pretty fast because I know what a graph looks like and I could use those characteristics to help me. If I didn't want to do that, then that's where your table would have come in. All right, so I would have had my table and I would have been looking at 0, or not table, but my calculator, 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right, and then I would use my calculator to get those. So I'm going to do that pretty quickly, all right, just so that you can see it. But I would have had -2 plus cosine of 0, and I got -1. -2 plus cosine of pi over 2. And I got -2. Do it again, but just with pi. -3, do it again, but with 3 pi over 2. -2, do it again, but with 2 pi. And I got -1. Okay, so 0, -1, check. Pi over 2, -2, check. Pi, -3, check. 3 pi over 2, -2, check. 2 pi, -1, check. Okay, so like I said, I don't care how you do it. I don't care if you use your calculator to help you. It's not a bad idea to check that anyways, especially on an assessment. But if you know enough about your graphs, then of course you could use the original before shifts and then, shift it down yourself. I just don't necessarily need to see this graph. Okay. I need to see this graph. So a lot of times people will do it maybe in pencil. and then just erase it. All right, so y equals k is my midline, and here is that midline. All right, why is it my midline? Because 1 here, amplitude of 1 here. So it's like where everything comes together in the middle. All right, so my points on y equals k are pi over 2, negative 2, and 3 pi over 2, negative 2. My maximum points, I have 2 at 0, negative 1, and 2 pi, negative 1. My minimum is pi, negative 3. Forgot to do the midline, but the midline is at y equals negative 2. All right, so that was your first one. Your second one, the amplitude is 1. The period, b was 1 again, so 2 pi over 1 is just 2 pi. So same thing as the other one, so that'll make it a little bit easier. So we have a 0 and 2 pi, which is 4 increments away. Pi, half of pi is pi over 2, 3 pi over 2, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3. All right, so this right here, the 3, means that it's going to go up 3. Okay, so that'll kind of help me with my shifts. Now it's a sine graph, so where does my sine graph start? 0, 0. So think about that. So it starts at 0, 0, but it's going to go up in amplitude, down in amplitude, down in amplitude, back up in amplitude. So this is what my original sine graph would look like. But I have to go what? Up 3. All right, so I'm going to go up 3, up 3, 3, 3, and 3. So everything is up 3. Make sure it's curvy, make sure it's rounded. It shouldn't look like V's, okay? So be mindful. So this is the graph that I'm looking at. Okay? All right, not the orangey looking one because that's just what I use to help me get my graph. Again, I could have easily done my, my x's, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And for simplicity's sake, if I would have done that, this would have been 3, this would have been 4, 3, 2, and 3. Okay, is what you would have gotten if you did do that in your calculator. All right, so my midline is where it all meets in the middle. So right here, this is my midline. All right, and my midline then is at y equals 3. The points on my midline are 0, 3, pi 3, and 2 pi 3. My maximum is pi over 2, 4, and that's it. All right, and then my minimum is 3 pi over 2, 2. Do be mindful, like when you do have like this extra graph on your paper, you don't want to mess up and start doing this part over here and answering questions based on this function right here without the shift. So make sure that you're bringing your attention to the one that was actually shifted. All right, so those were the problems that I wanted you to give a try on your own. All right. All right, so let's take a look at a couple more. All right, so this one is going to have a vertical shift. I want to make sure we get practice with sines and cosines. All right, so, and actually, I mean, these are similar to what we've already done. So if you'll go ahead and kind of pause the video and give these a shot on your own, give you some time to try 3 and 4. All right, so hopefully you tried number 3 and 4. So let's go ahead and go over them. So first of all, this one has an amplitude of 1. This negative 3 means that it goes down 3. Okay, B is 2. So my period is 2 pi over 2, which is just pi. So 0 is always right here. 1, 2, 3, 4 increments over will be pi. Half of pi is pi over 2. Half of that is pi over 4. And then 1, 2, 3 pi over 4. So I'm counting, but again, you could obviously do the pi times a quarter, pi times, a half, pi times 3/4 to get those markings as well, like we've already done. And then my y-axis. All right. So with this one, we can use our calculator. We could use, just what we know about cosine graphs, but it is a cosine graph. So it's important to know that it starts at 0 amplitude and the amplitude is 1. So it would start at 0, 1. All right. And then go down, down, up, up. So in yellow, this is my graph before shifts, but it's going to go down 3. So 1, 2, 3, 1, 2, 3, 3, 3, and 3. Curved, uter-shaped looking graph. Okay, so this is the graph I'm looking at. So my y equals k is going to be my midline. So that happens at -3. So y equals -3 is your midline. And you would have pi over 4 -3 and 3 pi over 4 -3. My maximum, I have 2, so 0, -2, and pi -2. I have one minimum at pi over 2 -4. Okay, so that's where all of those came from. Again, I didn't show it on this, but you could, of course, do your calculator. And if you did your calculator, you would find these same values. Okay, number 4, you have a vertical shift of up 2, but I have an amplitude of 2. I have a B value of 4. Okay, so those are some of the things that I should see right away. So my amplitude is A equals 2. My period would be 2 pi over B, which is 4, which gives me pi over 2. All right, let me change color so it's a little darker. So 0, 1, 2, 3, 4 increments would be my period of pi over 2. And then I need to get these other markings. Now, it's harder for some of y'all to think about, well, what's half of pi over 2? What's half of that? So on this one, I'll show you like the quarter thing again. So to get this one, it's going to be 1/4 times your period of pi over 2. Well, that's pi over 8. This is the halfway mark or the 2/4 mark times pi over 2, which would be pi over 4. And then this is going to be your 3/4 mark. So 3 pi over 8. Okay, but of course you could obviously count that as well, but this is just a reminder of how to do that. All right, and then my y-axis, go ahead and set that up. All right, so we have a sine graph this time, and where does sine start? Well, it starts at 0, 0. All right, now my sine graph has an amplitude of 2, so I'm going to go over and up 2, down 2, down 2, back up 2. So this is what this graph looks like before I shift it. Okay, before shifts. All right, so I put it in yellow because I don't want it to be super bright. All right, so now I'm going to actually shift it. All right, so I'm going to shift it up 2. So everything is going to go up 2. Now, I want you to kind of think about what you could do to save time if you didn't want to draw this whole entire yellow thing out. The fact that I know it would have normally started at 0, 0, but this tells me to go up 2, I would start here, and then I would go over and up an amplitude, over and down an amplitude, over and down an amplitude, over and up an amplitude. Or I could have the yellow and just simply count 1, 2, 1, 2, 1, 2, 1, 2, and so on. Okay, but this is what the graph does look like. Okay, So the green one is what I'm going to look at. All right. Yellow one is just there to help us. Okay. But the green one's the one that we are looking at to answer all of our questions. All right. So our midline is at y equals 2. And the points on my midline are 0, 2, pi over 4, 2, and pi over 2, 2. My maximum, I have 1. It's at pi over 8, 4. And I have a minimum at 3 pi over 8, 0. Okay. A quick reminder for anybody that needs to see it is if you needed to, you would create your little, points here. And I would have 0, pi over 8, pi over 4, 3 pi over 8, and pi over 2. All right. And I'll show it to you in the calculator for anybody that needs to see it just another time. So in the calculator, I would have 2 plus 2 sine of 4 times 0, which is 2. And you'll notice that we plotted 0, 2 right here. All right, I'm going to do it again, but I'm multiplying it by pi over 8. And I got 4. And notice that we have pi over 8, 4. I'm going to do it again, but it's going to be pi over 4 this time. And I got 2. And notice we have pi over 4, 2. Do it again with 3 pi over 8. And I got 0, which is why we're at 0 here. And one last time at pi over 2. And I got 2, which is why we're at 2. Okay, so just a quick reminder of how you would utilize your calculator to do that. All right.